All right, welcome to Security and File Permissions. Here is one of the most famous XKCD cartoons for Linux. And, make sure you smile when you see this cartoon in the future because you'll know what it means after we're done with this lecture. Okay, so let's get on with it. As always, make sure you're doing the reading and reading the required material at the very least and doing more exploration into the man pages for any specific commands you use and you don't understand or just want to learn more about. And of course, looking online for neat and interesting articles. There's a plethora of articles literally about every command in Linux, so you can have a good time. All right, so once you spend enough time in the Linux command line, you will definitely forget to add sudo at times. And instead of hitting the up arrow key, because that doesn't always work, and I can show you an example of that in class, but a simple way to add sudo to a previous command is called sudo space bang bang. So here's a parody of that XKCD cartoon, and of course sysadmins being insecure like to flaunt their elite skills and call other people's noobs. But you're not going to be like that when you become older and wiser because you don't want to sound like that, right? Okay, so remember sudo bang bang. I have to force myself not to use it when I'm making these demo videos because I want you to see the command. So I force myself to type it out, and sometimes I'll type sudo bang bang and then have to backspace it just so I can type the command out right. All right, so let's get on with the lesson. User account on our Linux VMs and have looked at the etc password file before, so that's great. Well, this is a great graphic shown here on the screen, that white box. Showing you how the fields are broken out in the etc password file. You start out with the user ID, X for the password. It's always going to be X because the actual password is stored in hashed form in the etc shadow file. Then there's the user ID, the user group's ID, and then user info like home directory, what shell is defaulted in, etc. Now, every user has a user ID starting at 1000 and up, and a primary group ID associated with yourself. So like, for instance, the Sal user ID is going to have the Sal primary GID group ID. But you can be added to other groups as well, and that's what we're going to do in some of our hands-on stuff as we walk through in later slides. It's important that the root user always has an ID of 0. And system accounts are generally less than 1000 in terms of their ID number. Service accounts, not system accounts necessarily, also start at 1000 and above, but they may or may not have all the other info of a regular user like a home directory or a shell assigned to it. So remember, service accounts are used by system services such as web servers, mail transport agents, databases, etc. Service accounts can be created like ordinary user accounts, using the user add command or the add user command. However, service accounts are typically created and configured by the package manager upon installation of the service software. So even as an administrator, you should rarely be directly concerned with the creation of service accounts. And most importantly, service accounts usually have no login shell associated, so they can't be abused by attackers. That's good info to know. Now, there are a number of useful user-related commands such as ID, which lists current info about users on the system. The last command displays information about the last logged in users. It's pretty cool. You should check it out. It's pretty convenient and handy when you need to track login activities or investigate a possible security breach. The last command will, by default, take the system log file from var log wtemp, and we'll talk about that a little later, as the data source to generate reports. Super interesting, and I mean that, it's super interesting, is the last B command, which details failed login attempts. You'll see why that is interesting shortly when I run the command on my DigitalOcean VM. And you also need to run lastb as sudo to see the results. Now, there's a little article link on the slide there about the last command. Check it out. It's a nice little article. And the reason I put it there is because there's an article about every command in Linux that is probably got some interesting information. Now, moving further down, the who command lists active logons on the system, which can be informative, especially if you see logins from users you don't expect to be logged in. Now, the who am I command is useful when you want to see what the terminal shows you logged in as, and you may forget, and sometimes you don't have that information at the command prompt, which you will see here in a little while as you switch to a different user that we create later. You'll see that the command prompt is just a $sign. And you're like, who am I? That's a great question. Type in who am I? And then there's the W command, shows not only who is logged in, but what they're doing at the time to a certain extent. So best way to explore those commands, of course, is to use them. So let's go ahead and run through these commands. Okay, we're going to start out with the ID command. It shows you who's currently logged in. And of course, you can use ID with the username to see specific information about a specific user. And if you go to the man page, you'll see there's a bunch of different options to use, but primarily you're going to use an ID with blank or with a particular user's name on there. Go ahead and type in last. Last will show you all the login, successful login attempts, and goes back all the way to January in this particular event. Now let's go ahead and look at the sudo last b. Remember, you need sudo. These are failed login attempts, and you should, if you're using your DigitalOcean server, probably see a whole bunch of failed logins. That's because there's a bunch of people constantly scanning the internet trying to brute force into SSH on anything they can find, assuming there's bad passwords, which is why you don't use a bad password. Let's go ahead and clear that screen. We already know who I am, so just type in the who command. You get to see currently only Sal is running on the system. W will give you a little more information, like, hey, I am actually logged in from the 162.243 IP address. So W does give you more info. Okay, moving on. You're all familiar with the least privileges model by now, and Linux does a pretty good job of forcing you to escalate privileges to execute important or dangerous commands. That's why you have to do sudo to do so many actions, and you should never, ever administer a system logged in as root, because if you do, you won't be able to stop yourself from doing stupid things like when you are as a regular user with sudo access. Of course, you're by now familiar with the sudo command, which allows you to escalate your permissions temporarily to administrator to execute commands. Sudo stands for substitute user do, or some people call it super user do. However, you do use the su command to switch users, so substitute user is a better definition in my opinion, but whatevs. I'm not going to fight anyone over it. Now, if you want to switch to another user, you use the command su space dash and then space the username. The dash after the su, so su space dash, will move to that person's home directory if there is one, a topic we will talk about shortly when creating user accounts. Now, there are a number of important access control files, and you've seen some of them already, like etc password and etc shadow. The etc group file, as shown on the slide, provides details about groups on the systems, members of the groups, group IDs, etc. Now, groups can have passwords assigned just like users. Where are those passwords stored since they're not an etc shadow? Well, of course, there's an etc gshadow, which provides details like hash passwords for groups. Then there is the etc sudoers d directory, which is a subdirectory of the etc directory on Linux machines, and it is used to store files that define special sudoer configuration. These files are read by the sudo utility every time you type it, which allows authorized users to execute commands as other users or with elevated privileges. And you can configure the sudoers.d file to really kind of narrowly define permissions based upon different sudo users and groups and stuff like that. So it's a very important file, but unless you are a Linux system administrator in a heavy use organization, you're probably not going to mess with that file. Now, this slide shows a nice picture of how to read the very important etc shadow file. Now, what do you need to know here? First, you need to know that you need to do sudo to see the etc shadow file. So catting etc shadow, you're going to have to sudo first. Also, you need to understand that what bang bang or the exclamation points mean. So if it's bang bang, disabled account. If it's bang followed by a $sign, it's disabled and had a prior password hash. Should know what those two mean. And that enabled accounts are always going to start with the $sign without the bang, without the exclamation point. Also, you probably don't need to memorize what the different hashing values are, so $1, 5, 6, and Y. But you should know how to find the salt and the password if shown an entry from Etsy Shadow. So if you look here, the Sal account, this password is hashed with MD5, not the best hashing algorithm, but hey, Linux did it for me. The salt is between the next two $signs after the $1, so capital L, capital M, L15, Z, capital S, capital N. That's the randomly generated salt. Then between the next $sign and the colon is my hashed password. And my password is none of your business. Anyway, you should know generally how to read that. And there's other information about the passwords that follow in Etsy Shadow, but we don't need to worry about that at the moment. Okay, so we just talked about all users that need admin rights, aka sudo privileges, need to be in the sudoers file. Now, one way you may think to do this is to edit the Etsy sudoers file, right? Well, no, but let me explain. The main job of the sudoers file is to define which users and groups can use sudo. However, this file also contains some options that will allow you to configure sudo's behavior. Now, some of these options include the ability to change the timeout length of privilege escalation, so you don't have to keep typing sudo, or the password for sudo. There's a bunch of options that you can manipulate in here, but to change that file, you do not use a regular editing program like Vim, VI, or Nano. You should only edit the Etsy sudoers file using an application called the VI sudo. And this is to ensure that if you mess anything up by using a regular text editor like Vim, you won't brick your system. Because you could. And only when you need to change how sudo works will you ever use VI sudo. So unless you have a very specific reason to change how sudo works, you'll just leave the Etsy sudoers and sudoers.d files alone. In almost all regular use cases, all you really want to do is add users to sudo. And the way to do that is not editing the Etsy sudoers file, but to type a command like sudo add user, whatever that user's name is, and then sudo. So that's right, you just add the user to the sudo group. No need to edit the Etsy sudoers file. Now, lastly, the Etsy sudoers.d directory allows you to create files that give specific sudo privileges to specific accounts. Now, this can come in handy when you're required to give a service account some sudo privileges to function, but you want to minimize the amount of admin rights that that account has. But again, typical Linux administrators are not going to touch the Etsy sudoers file or add files to the sudoers.d directory. Hope that's clear. All right, stick with me here. User add is a command in Linux that is used to add user accounts to the system. It is, however, just the symbolic link, you remember what those are, right? To the add user command. So the user add command is a symbolic link to the add user command in Linux. And the difference between both of them is that the user add command is a native binary compiled with the system, whereas add user command is a Perl script which uses user add binary in the background, and it helps to make changes to files like Etsy password, Etsy shadow, Etsy group, Etsy G shadow, the ones we just talked about, and also creates a directory for new user and home. By far, the most user-friendly between user add and add user is add user because it does a whole bunch of steps. However, there are times to use user add when you don't want all of the things created, like you just want to create an account like a service account, and you don't want that service account to have a home directory or a shell. That's why you'll use user add. But if you're creating a user account, you tend to use the add user command instead of user add. So when executed without any options, The user add creates a new user account using the default settings specified in a file called Etsy default user add file, which if you look at that file on a base Linux install, and you can go ahead and do that on yours, there's not very much there. So what doesn't user add do? Plenty of things. If you just use user add to create an account, you won't get a password for that account. Therefore, that account won't be able to log in and you won't be able to switch to it. Again, why use it user add instead of add user, which kind of like either forces you to add a password or gives a blank one? Well, again, you use user add if you're creating a human user. If you're creating a human user, you'll probably always want to use the add user command, but user add is beneficial for more control when creating the account. So as with user del, so you can imagine we have a user add, which is a symbolic link to add user. Well, we have user del, which is a symbolic link to del user. Del user gets rid of all user configurations, but user del, you have to choose specific options to get rid of different pieces of information related to a user, such as home directory files, things like that. Now for the walkthrough, I'm going to use the user add command just to kind of show you the more painful way of doing it. If for creating this user called Elvis, had I used add user, I would have not had to gone through some of the steps that you'll see as I walk through these hands-on activities. Since we're talking about adding users, there is a very useful directory you need to know about. It's called etsy-skel. And the etsy-skel directory, standing for skeleton, contains files and folders that will be copied in the new user's home directory, or their login directory. When that user is created using the user add or add user command. The skeleton directory allows the administrator to create new users having the same files and folders in their home directory, so like a template. A good example is shown on the slide here. Like in your etsy-skel, you could have a copy of a company policy. It says here harassment policy, but maybe a user access policy or something related to the Linux infrastructure, because that's probably what you're going to look at when you're on Linux. Now in Linux, there's a concept of users for those who manage the system, and then there's the concept of groups, which is basically a logical mechanism to manage a collection of users. Groups make it easy to manage users with, say, the same security and access privileges. So it's worth knowing that a user can be part of different groups, not just one, not just two, it could be part of a whole bunch of them depending on what their purpose is. The group add and group del commands allow you to add and delete groups, but there are limitations, like you can't delete the primary group of a user account. For example, going back to my Sal account, you can't delete the Sal group when the Sal user still exists. All right, let's get into this set of actions, and you're going to have to try to follow along. Oh, you're not going to have to try to. You are going to follow along, and you might want to take some notes and listen to my explanation of the commands that I run. Okay, start off just by making sure you're in your home directory, doing ls. Okay, great. What present working directory I'm in? Okay, I'm in Sal. So I want to create a user named Elvis. I'm going to type user add Elvis. Oh, can't do that because I need sudo permission. So I sudo user add Elvis or sudo bang bang, right? I just showed you sudo bang bang there. I promise I won't use that too much. I'll type out the command. So sudo user add Elvis, it's there. I entered my password. Now let's check to see if there's an Elvis account by catting Etsy shadow. And I'm going to go ahead and grep for Elvis just so I don't see the whole file. And, oh, got to sudo it, right? So instead of sudo bang bang, I'm going to go ahead and type in sudo cat, and then you see there's Elvis, but notice what is in the front there. You have an exclamation point. So I don't even have a password for this thing yet. So if I try to go ahead and su into Elvis to go ahead and create this cool file, probably going to have some issues. So let's go ahead and try it. su dash Elvis. Go ahead and type in any password, doesn't matter, never set one, and it's going to error out. Now that's a problem. So what to do? Let's think about it. Maybe, you know what, we're going to go ahead and delete Elvis and do it using one of the options from the user add command, okay? So we're going to go ahead and clear the screen. I'm going to go sudo user del Elvis. Just get rid of Elvis and then verify that Elvis isn't there by looking at the Etsy shadow. No Elvis, great, wonderful. So now what should we do? Sudo user add. Well, let's go ahead and man the user add command to look for what we want. So go ahead and scroll on down. There's a bunch of different options. I'm looking for one that's TACP for password, but there's going to be something super important in here when we get to that TACP, which is why we never use this command. I'm showing you not to use it. The encrypted password is returned, but TACP actually sets an unencrypted password. That's crazy, right? So sudo user add TACP, then whatever password you want to use. I'm going to use Elvis123 for Elvis. So now I'm creating a new account called Elvis, and I gave it the password of Elvis123. And look what happens when I grep the shadow. I can see the password. It's not hashed. That's not good. Yikes. So let's not do that, okay? TACP is unencrypted, and we don't really ever want to use this. So what can we do? Let's go ahead and get rid of Elvis. Go ahead and check to see if Elvis is there. Go ahead and add it. Now, change the password to Elvis by using the sudo password Elvis command. Type in Elvis's new password, Elvis123. Type in Elvis123. Same password as before, okay? And we go ahead and look at our Etsy shadow. Notice we have a hashed encrypted password of Elvis123. You know that, I know that because you're watching the video, but no one else does. Now let's go ahead and su into Elvis. Type in Elvis123 as the password. Notice it says you don't have a home directory. And notice how the $sign there doesn't tell you who you are, right? Present working directory, I'm still in Sal because that's what I switched from. That was my present working directory at the time. So when you do user add and all you do is create a user account, you literally are just getting an account with like nothing else, not even a password. But now let's go ahead and see if we can touch in the Etsy directory the cool file. So touching it would create it, but we can't because we don't have permissions, right? So we don't have permissions to get an Etsy. We have to add Elvis to the sudo ers file. How do we do that? Exit out of Elvis, sudo add user Elvis sudo. So done. And now let's check to make sure it's actually done. So I'm going to ID Elvis, and notice Elvis now has a group ID of 1002 for Elvis, and then there's, you don't see it on the screen there, but it's 27 for the sudo group. I'm sorry, I had to cut it off. Now when I su to Elvis and I type in the Elvis123 password, it says I don't have a home directory, but yes, I'm in, and I can sudo touch /etsy/coolfile. So I can create a file called coolfile and then check it out by doing an ls-lh of the Etsy directory. And wow, that's a lot of files. So maybe, now here's what I was going to say. Notice I can't hit the up arrow. Why? Well, because I'm su'd in and that function doesn't work in shell. That's a bummer, isn't it? So I'm going to go ahead and keep trying to hit the up arrow. It doesn't work. Fine. Let me try my C, my alias. Nope, that doesn't work either. Remember, because it's a local variable. So I go ahead and type clear, and I have to manually type out ls-lh, and I'm going to pipe that. I'm going to ls-lh Etsy, and I'm going to pipe that into grep cool file. And the question on the screen is, who's it belong to? Root. Why? Why does it belong to root? Because you su'd to create this file. Okay, so go ahead and exit out of that, and let's keep going on with the rest of the tasks here. So We exited Elvis. We're going to use ID. Okay, so we want to remove Elvis's sudo permissions. That's sudo del user Elvis sudo. And then we test that by doing an ID. Also, you can do groups Elvis. And you'll notice that Elvis is only in the Elvis group. And before, if you did groups, it'd be groups. You'll have Elvis and sudo. Now next thing we want to do is create a group with the 111 GID called superstars. So it's group add tac G 1111 superstars. Got to sudo that because you're creating a group and that can have privileges associated with it. So instead of sudo bang bang, go back to sudo group add. And then what we want to do is add Elvis to that. So sudo add user Elvis superstars, just like we did with sudo earlier, except with superstars is the group name. And then we go ahead and verify it. How do you verify it? Do a little ID Elvis. Oh, look, he's got 1111. It's broken off there. But when we type groups, you'll see groups Elvis. Elvis is in Elvis and superstars. So good to go. So I just showed you how to add a password to Elvis using the user add tac P option. That's good, right? No. No, it's not good. It's not good because that password was added unencrypted to the shadow file. So if anyone can get access to it, they can see the password unencrypted. That's bad. So what did we use? Instead, we used the password command to add a password safely for Elvis. So the moral of the story, when you're creating a user, use the add user command to set up a proper password. Or if you're not because you can't, then use the user add command and then the password command to safely set up a user password. If that doesn't make sense, go ahead and watch what we just did a minute ago. Go through it yourself and you should see. Now, while the password command is primarily used to change your user's password, it is also a powerful administrative tool to lock accounts or force a user to change their password. The tac D option deletes a password, which effectively disables a user from logging in. However, if you use the tac L option, that will add the bang, the exclamation point to the Etsy shadow file for that user we discussed earlier, will lock that account, not delete or change the password. If you use the tac D, a user's password, you would have to change or add a password for that user to gain access again, as you will soon see. But if you lock the account with a tac L, then a tac U will unlock it without requiring a password reset. So that's useful stuff. All right, let's go ahead and go through the activities that are shown right here. Okay, so we're starting with an Elvis account. Let's go ahead and verify that. I'm going to go ahead and grep Etsy Shadow. Notice I have an Elvis account. It's got a password. Wonderful. Now I'm going to go ahead and lock that account with the password tac L option. And it says password changed. Let's go ahead and verify that by looking in Etsy Shadow. And notice now there's a bang in front. We have a locked account. So Elvis's account is locked. Wonderful. Now we're going to unlock Elvis's account and verify that works. So we type sudo. Go ahead and let's SU into Elvis just to make sure that while it's locked, we can't get in. Again, it doesn't matter what password you type, you're not going to be able to get in. So now let's go ahead and sudo password tac E to force Elvis to change his password when he can unlock it. Now, does that mean he can do it now? Try to go ahead and SU into Elvis. The account is still locked, however, so the SU is not going to work. So we have to unlock the account with a sudo password tac U Elvis, unlock the account. Now we can go ahead and SU in and watch what happens. Type in a password, Elvis123. Tac E is going to tell us, hey, you're required to change a password. So I'm going to change it. So type in current password of Elvis123. I'm going to change it to Elvis1234. And the password is going to be Elvis1234. So everything's working nicely. And look, we have a $sign. We're in as Elvis. So I'm going to go ahead, clear the screen. See that I'm still in my Sal home directory, even though I am Elvis. Now when I exit out, I hit a W. You see it's just Sal is the user. Okay, go ahead and clear the screen. Now the next thing we're going to do is disable Elvis's account and verify it's disabled. So sudo password tacd Elvis. Go ahead and see what that looks like in our Etsy shadow folder. Cat Etsy shadow grep Elvis. And you'll notice that basically the password's deleted, and no, Elvis can't do much. If you try to SU into Elvis, you're not going to be able to use password 1234 anymore. As a matter of fact, it doesn't exist because you've disabled that account. Great. Even though you have the $, you're not in as Elvis. You go ahead and exit out of that. You wouldn't be able to do anything anyway. So now you go ahead and ID Elvis, and you'll notice that it's in the Elvis and the Superstars groups. What we're going to do is we're going to delete Elvis from the Superstars group. So sudo del user Elvis and Superstars. I think I have Superstar written down, but I typed in Superstars earlier. And ID Elvis, and you notice that's gone. If you do groups on Elvis, you'll notice that Superstars is gone also. Now, the last thing it says is delete Elvis's account, remove his home directory and other stuff. So if I go to sudo del user Elvis, basically you're removing what little was added to Elvis when you did the add user command. And when you go into sudo cat etsy shadow or password and you grep for Elvis, Elvis is not going to be there. Now, if you use the add user instead of user add command, there would have been a lot more stuff, but you don't have that problem because you only really created a basic user account and a password. There you go, with the user add command. Elvis does not exist anymore. We look, there's no more groups named Elvis, so we're good to go. All right, well, that was fun. It's always fun in the command line, right? Well, let's now move on to Linux file permissions. Also very fun. And they look hard at first, but once you spend a little time on it, it's really quite easy to deal with. Now, what you see there on the far left, the first column of the permissions, you'll have either a D for a directory, L for a symbolic link, you know what that is, and a dash if it's a file. And that's it. Those are the only three things that'll be in that first far left column. The next three columns of columns, if you want to call it that, are all the same, but for different user rights and permission. The first collection of three columns is for the user/owner of a file. The second grouping is for the groups, yes. And then the third grouping is for anything other than the user in the group. So it's basically other users that aren't the user and aren't in the group. What are their permissions related to that file? And there are three basic permissions. There's read, write, execute, which you are all already familiar with. So let's get into some more about this. So taking a look at what I have shown here, I did a little ls-tech-l on a directory, and it's got a bunch of different files. So on the far left here, the first column shows that I have the dash for a file, some directory, some dashes. Oh, got a symbolic link, and when you go over to the end, you see that host file 2 is symbolically linked to the document's host.backup file. Okay, and so you have what you expect to see, either dashes, Ds, or Ls in the first column. Now, if you move on to the second column indicating right here, the second column that I have highlighted, not the read-write permissions, the second column indicates the number of hard links pointing to that file. So for a directory, that means the number of subdirectories plus a link to itself. So if it's a directory, you'll always have at least 2, if not more. If you have subdirectories underneath it, it'll be more than 2. So in particular case, we have like this row right here, D, I've got 7. So it includes 2 for, it's a link to itself, and then it has 6 other things underneath it in the labs directory, which you could look at by going in and drilling down into the labs directory, okay? Now the third and fourth columns show the ownership information. So the owner is Sal, and then the group is Sal, in this particular case because it hasn't been changed, right? You come over here, that's your file size. So the fourth box I have, and then the sixth box shows the precise date and time, also known as a timestamp, when the file was last modified, not when it was created, when it was last modified. Then, of course, the seventh and last column, which you don't see a box for, would be the file name and related information, or directory name. Okay. So let's get back into the read, write, execute permission stuff. Now, there are a couple of different ways to represent and change directory and file permissions. The first is either with the R, W, and X nomenclature, and that's called the symbolic notation. And the second is with numbers. And I find numbers are easier to deal with in this, and you'll see some examples here in a second. So the numbers to remember are: read is equivalent to the number 4, write is equivalent to the number 2, and execute is equivalent to the number 1. Therefore, any file with executable permissions must always be odd. It'll either be a 1, a 3, a 5, or a 7. Okay? Likewise, any directory with an odd permission allows that user or group to access the directory. So files actually execute if you have the execute bit set on it, so you have a 1 or an odd number. And then for directories, if you don't have execute, in whatever it's user, owner, groups, or others, if you don't have execute set on that particular group won't be able to actually access what's in the directory to read it. So in both cases, even though files actually execute and you access directories, you won't be able to execute that action. R means the same for both files and directories. A user can open and read the contents. And W for directories means a user can create or delete files in a directory, while for a file, write means that the user can edit or delete that particular file. Okay. Now here's where it can get a little confusing and why I recommend the number-based system for setting and changing file and directory permissions. The chmod command for change modify. The chmod command is used to modify and set permissions on files and directories and allows the use of both symbolic or numeric modes. And you can even mix them, which is ridiculous. So let's say you have a file called file.txt. And you want to see that you want to set that file's permissions such that the owner has full read, write, execute permissions. The group users can read and execute, but not write, and then others can just execute. In symbolic mode, your command would be chmod u plus rwx, comma, g plus rx minus w, comma, o plus x minus rw, space, file.txt. That's ugly and awful, right? The numeric alternative would be chmod 751 space file.txt. Much simpler, harder to screw up. You'll know that for the owner, 7 permissions, 751, 7 is read, write, execute. For groups, it's 5. So the only way to get 5 out of 4 plus 2 plus 1 is read plus execute. So groups have read and execute. And then the 1 is just execute for others. So much simpler than using the symbolic notation. And lastly, see the note on the slide. If you change a directory's permissions, those permissions will not propagate to subordinate directories or files without the TAC capital R option being used for chmod for that recursive action to go through it. So keep that in mind if you have to set permissions that are supposed to go through all the child directories in a particular file structure. Okay, now there will be times when you want to change a file or directory ownership, like when a user departs or someone new takes over an administrator role. The chown for change ownership command, chown command, can be used to change user and or group ownership, but as the cartoon on the slide shows, you need to use chmod to change file and directory permissions, not ownership. So Changing ownerships, you hand over the key, but for modifying permissions, you have to use chmod. Another way of identifying users belonging to a group is to use the group mems command with the tacg option, allowing you to identify the group name afterwards. So you can do sudo group mems tacg superstars, and you'll see all of the users associated with that group. So it's actually kind of neat command to know. Okay, now on to something that causes a lot of confusion for a lot of people, and it should not. We're going to try to simplify this in the next few slides. They're called special bits or permissions. And there are 3 of importance and 2 are closely related. The 3 are the sticky bit, the set UID, and the set GID. Start with the most confusing one, which is the sticky bit. The sticky bit is only ever seen in the others permission. So we're talking on the far right of the file or directory permissions and represented by a T in the X position, so the execute position. When you see a T there, that's the sticky bit. And the sticky bit is control certain temporary file directories. It's the only time it's used. Temporary file directories, such that only the owner of the directory can delete that directory. Now, why isn't the T then in the user owner permissions instead of all the way at the end for the others group? Because it is. So the sticky bit, far right at the permissions, in place of an X, when that is a T, that means the only person that can delete those temporary file directories is the actual user. The user owner of that particular account and file system. Okay, now the set UID and the set GID, they're related. And it comes to how programs are run. The set UID, SUID is kind of how you'll see it written like there on the screen, allows others to run a program with the privileges of the file owner. Therefore, if the file owner is root, like if you're running sudo and other commands like that, the program executes with root permissions, so it is important to be careful about when you have the set UID set. Because when SUID is set, you will see an S instead of an X in that first grouping of file permissions for the owner/user file permissions for a file. Okay? Great. Now the set GID, which stands for set group ID, does something very similar to set UID. It allows a file to be executed with the permissions of the associated group. Now, in this case, the group X, which is the middle grouping there, would be replaced with an S in the file permissions. So we're, instead of execute for set UID, you'll have an S in the far left X position. And for set group ID, in the middle group permissions where the X is, there would be an S if set GID is set. And you can use set UID and set GID together. When would you want to do that? Not really important, just know that you can, okay? Now, as seen on the previous slides, there are 2 ways to set the set UID, the set GID, and the sticky bit. So kind of like when we were doing the chmod before with the numbers and the symbolic notation, again, you can do it however you want, either symbolic, numeric, or you can even mix them, but I recommend, again, using the numeric. It's much simpler. If you're using symbolic notation for setting permissions, if you're going to do the set UID, you would do chmod u plus s, because it's going to be in the user group, right, the owner permission. For setting the set GID, it's going to be chmod g plus s, so the G for the group permissions. And then if you want to set the sticky bit, is it going to be chmod o plus t? No, it'll be chmod plus t to set the sticky bit. Why? Again, because. Now using numeric notation is simpler because you just put a number in front of, let's say, your 751 settings permissions. So set UID is 4, set GID is 2, sticky bit is 1. Therefore, if you want to set the set GID bit on a file that has 755 permissions, you would type chmod 2 for setgid 755, the permissions on the file, and then the name of the file. All right. Now, since we brought up temporary files when talking about sticky bits, let's talk about temporary files some more. The /temp directory contains all the required files that are going to be required only temporarily during program execution. Now, in the case of any crash or unexpected event, you can retrieve your file from that directory, that temp directory. And you can also see which subprograms are being used during the execution of a program by looking in the temp directory. Now, when you save your file at the desired destination and exit the program properly, all the temporary files in /temp or whatever associated documents are going to vanish, leaving the directory empty. And you won't be able to pull them back. They will be gone. Now, if it is not emptied, then after a reboot of your PC, it will definitely become empty because that's how the /temp directory works. Now, a little bit confusing. Okay, so in Linux, everything is a file, although some files run and execute as a process. So temporary files are used to store data for a short period of time, hence the temporary, right? Now, for example, when you're using the htop command, which we've gone through before, your system is actually using temp data to show you the process IDs and the associated information for processes currently being run on the system. And all those things are files. So there are 3 important temp file directories for you to know about. There's /temp, /vartemp, and /run. We're going to talk about those briefly to the extent you have to know that. Okay, so /temp and /vartemp. The main difference between them is in their retention period for the data. So data stored in vartemp is more persistent than in the /temp. By default, data kept in the /temp directory lives for up to 10 days, okay? Now, again, if the program finishes running and decides to delete the information, it'll go away. But by default, Linux will get rid of any data in the /temp directory no later than 10 days. For the vartemp folder, it's 30 days. And the main difference between these two is the fact that the vartemp data lasts longer. And one other thing, the vartemp data persists between reboots. For vartemp, typically when a program that's using the temp folder is done, it'll clear itself out. If not, when a reboot of the machine happens, that /temp data will be deleted. Vartemp data will persist between reboots because maybe it's needed again the next time the program boots up, but it's not needed forever because you want to dump that cache data out and have fresh data next time it runs in the future. And the last of the temp directories, and the last slide in this presentation is the /run directory, and it's a relatively recent introduction into Linux as another temp file system that is used specifically during the boot cycle to hold runtime variable data that's no longer needed after the system boots, and it is cleared very quickly after the boot is complete. So much faster than /temp, which is up to 10 days, and vartemp, which is up to 30 days. /run directory, temporary data needed just for the boot, and then when the boot is done, that /run temporary data is deleted. Okay, and that's it for this lecture. Make sure you take the time to run through all of the commands discussed in this presentation on your own Linux VM to help reinforce the purpose and the use. Now, even though I purposely made some errors while I was typing things or trying to execute things I couldn't execute, you should at least go through the commands to do the things that the slide box said you were supposed to do so that you understand what those commands do. If you have any questions, you know how to get a hold of me. Aloha.